Okay, so recently I put servos on my machine, and I'm using the Stepper Online A6 100 watt servo, and they have a rated continuous torque of 0.32 newton meters, and I believe the peak is 1.2, 1.3, 1.32, something like that on the peak torque. And the motors I had in here were the 2504 LDO long shaft motors, and they, I believe, are 0.55 newton meter motors. And I was concerned that that these servos wouldn't have enough torque, being 0.3 versus the 0.5, or I would be limited to a lower speed than I was getting with the 2504s. And the 2504s, I could run as much as about 80,000 acceleration at a speed of about 600. It really depends on the model. If there's a section that's got a long straight line, it might skip steps. It just depends on the model. So I thought for sure with these I wasn't going to be able to do that fast, if the steppers had the 0.55. So but these will run, I haven't tested any more than 2,000 millimeters per second at 150,000 acceleration at about 150 square corner. They take that. It looks effortless to me. It just effortless, but you can't print that fast. So what's the point in testing more is kind of what I'm thinking. Plus, once you really start running that fast, you're going to probably have lubrication issues on these rails. So anyway, enough of that. So I did some tuning on these drives, and of course initially I did auto tune on one motor for the gantry, and I just disabled the other motor and then ran it. And when the motor's disabled, they still move freely, so it was able to actually move and not bind on the other side, and then create some numbers in there. And then I transferred those numbers to the other drive so that they matched. And then from there I started to run, I started to look at the deviation at speed and the deviation from commanded on position, and then watched it. And then I started increasing the gain until I got an oscillation. And then I go a little bit lower than that, and then I start to lower the integral until I see overshoot again. And then you play with those two numbers until you get it kind of to where it's not over and undershooting all the time, but yet it's still not real sloppy. And then once I got those kind of sorted out, I ran some prints and I watched the speed deviation, the speed command, the position deviation, and the position command. And that's when I noticed that there was some overshoot and undershoot under heavy accelerations, like it's at start points and end points. From there, I enabled feed forward, torque feed forward, and then I started to increase the percentage of that until that overshoot undershoot was well under control. And you can easily see that in a plot. It's really easy to see. The software is really easy to see. So and now currently I think it's still a little too stiff. I think I need to back it down a little bit, but I don't want to do that until I've printed more with it. And you can change a little parameter, and then you won't really know the effect unless you have some observable idea of specific artifacts, and then you can translate those to a parameter. It can be kind of difficult. So if you kind of think servo all the time, parameters, I mean, it could be something else like your hot end or cooling. I mean, it can be something else, your belts or whatever. So now on this new setup, there isn't any change to the motion system. It's the same belts that were on there at the same tension. The mount is different. It's still direct drive, but I have a plastic piece here instead as an adapter. I don't really think that's going to mean a whole lot, meaning a difference. The motors are not in double shear. They are open. So Motor's got a rated radial force of 76 newtons, I believe is what it is, and I'm going to run them this way for the time being. These motors are going to end up out of the chamber. I don't feel comfortable with an enclosed printer in these servos, considering they're giving me these temperature limits of ambient at like 40°C, and I get 70°C in that printer. So I don't really want them in there, but I need to run some tests, and this is a great way to kind of A/B between steppers and these servos, and I have some old prints that I can look at. I probably should have made some more tests before I switched, but I didn't. And but I do have prints, and I have my memory of my prints, and I have some of them tucked away, and I can take a look and see and compare them. So, and currently now I'm kind of just printing circular objects to try to see if I can see what the artifacts are and see how the layer stacking is, and see if I can see any irregularity in the surface finish. So now this is a Mickey hand, and it's him giving the middle finger. Of course, he only has like 3 fingers, but it's a great model for testing circles. And I can already see on this particular print, I changed the layer height at this point, and it goes to 0.12. And I can already see in here, this machine has never, and I don't know if it's the hot end, I don't know what it is, I think it's related to the hot end, but I cannot print layers lower than about 0.15. I will get a strange pattern in there, and I can show you that pattern right here. Let's see here, I'm going to shine the flashlight here, and you should be able to pick that up. There's like this angular pattern on there, and you can see below the line, it looks just fine. It's that layer height, and it's a mystery that I sure would like to be solved, but I can't seem to solve it because it's out of my hands more than likely. I think I've tried every slicer, trick that there is, but this is Sunlu ABS, and it really looks dynamite. Really looks dynamite. I mean, you can see there's a different color change here between these 2 layer heights, and probably the fan is just too high. I'm only running about 15% fan for this print, but apparently that discoloration is also from surface finish. It can make it look much more fine. Maybe you can see the artifacts from the low layer height there. But yeah, it was a lot of work to do this. It was some money also to do it, but I just had this bug about these VFAs, and so far the VFAs are extremely better. Not saying there aren't any, there are some diagonal ones, and I don't know what that is. That's extrusion, or if that's tuning still, with the gain is too high or over undershoot or what have you. But there is some diagonal at about 250 to 300 millimeters a second. At 25 millimeters a second all the way up to 200, it looks excellent. I usually get VFA all the way till about 300 or 400, so I don't know, but this is all I've changed, and I'm shocked actually that this has worked out so far. I have high hopes, and so far I feel really good about it. So anyway, here's our little Mickey hand, and we've got some tuning to do, and yeah, well, that's it. Till next time.